Hello, I'm Andy Peel from the CCDC. Welcome to this video on searching for crystal structures in Conquest. In this demonstration, we will see how to build a substructure query and an elements query in Conquest, and how to perform a combination search using these. We will also see how to explore the results to find out more about CSD entries. We begin at the main search interface, which is accessed by launching Conquest either from the desktop icon or from the Start menu. Down the left-hand side, we see the Build Queries options, including the Draw button, which is where we access the structure sketcher from. The other options include the author and journal, name and class, and element and formula searches. Along the top you can see some of the other menus, including the View Databases menu, where you can view the contents of the different CSD subsets. We're going to create a structure search, so we click on the Draw button, which launches the Sketcher window. Along the top we have various menus, including ones where you can add 3D parameters to a substructure that's been drawn. These measurements would be taken from the structures during the searching process. Along the left-hand side, we see the tools for drawing and editing, including some common ring templates and also templates for some more complex molecular fragments that can save you some time when drawing structures. Along the bottom, we have quick access to common elements. We also have other elements available from the More menu, where you can launch a periodic table to select individual elements or combinations, including groups and periods. Along from that, there's a free text box where you can type an element symbol. And next is the button to select the bond type from the drop-down menu. This includes all of the different representations that are used in the CSD, but we also have the option for an unspecified type of bond, or a bond that could represent several specific types. On the right-hand side, there is a box where 3D parameters would be displayed if they'd been defined, and there is similarly a box for non-bonded contacts. Let's look at how we could search for some organocobalt complexes. We're going to start simply by drawing a substructure involving a tetrahedron of cobalt atoms. To do this, I'm going to go to the periodic table by clicking on More and then Other Elements. I'll then select cobalt from the first row transition metals and click Apply, and then simply left-click in the sketcher area. I'm going to add 4 of these, and then I wish to join these together with some bonds to form the tetrahedron. For this example, I want to join them with single bonds, so I'm going to leave the single bond from the menu selected. Next, we click, drag and release using the left-hand mouse button to join these atoms together. We continue to do this until all bonds are added. Okay, that's our substructure. As mentioned, the editing tools can be found on the left-hand side here. By clicking on Edit, we can select a structure. You could also make it bigger if you want, reposition it, and you could get rid of the individual atoms or bonds if necessary. So having drawn the substructure, we can either run a search now or store it for later. We're actually going to click Store because we will use it for a combination search later on. I'm now going to specify which element should be present in the search. To do this, I click on the Elements button in the Build Queries tab. This launches a new window where we can type the elements to be present. In this case, I want cobalt, carbon, hydrogen and oxygen. For this search, I would like the elements to be in the same molecule, and I don't wish other elements to be present in that molecule, so I'm going to untick that option. If you wish, you can also set the heaviest element permitted. I'm going to click Store, and you can now see that we have 2 queries in this Build Queries area. If you wanted to run those individually, you could select the query you want and click Search to bring up the Search Setup window. I'm actually going to combine the searches, so I'll leave and move to the Combine Queries tab up here. You can combine the queries such that both queries must be true, so that one must be true but the other is false, or you could allow at least one of them to be true. In this instance, I want them both to be true, so I'm going to drag and drop them into the must-have box. Then we can click Search at the bottom. You can type a name to make the search more memorable. I'm going to call this Organocobalt. Underneath that, you have a summary of the available databases. Underneath this, you have the option to select subsets by clicking on this button. On the right-hand side, you can see the various filters that can be applied. For this search, I want structures only with 3D coordinates. In the Advanced Options tab, you have the option to normalize the terminal H-atom positions. That might be useful if you're conducting a search using intermolecular contacts, for example looking at hydrogen bonds. We don't need to apply that here, so I'm just going to click Start Search. As the search runs, the hit list on the right-hand side is populated, and underneath the list you can see that there are 24 hits returned. The default view is the 2D diagram, and here you can see the tetrahedron of cobalt atoms that were specified in the substructure highlighted in red. Underneath that, you have a button Use Query, which will allow you to extract the 2D diagram for use in a subsequent search. Along the left-hand side, there are various different tabs relating to different fields of information. The All Text tab contains all of the text numeric information that's available. That includes publication details, links to the journal and to the dataset, a summary of chemical properties, crystallographic information, and then any further details about the experiment. These are broken down into different tabs just to make it easier to read. We can also view the structure in 3D by clicking on the 3D Visualizer tab. Here you can explore the structure in 3D. You can zoom in by right-clicking with the mouse and dragging, and you can rotate by left-clicking and dragging the mouse. Different visualization options are available by right-clicking in the visualizer area. From the drop-down menu, you can select display styles such as ball and stick. You can change the hit highlighting, so for instance you could add more contrast. Doing that, you can see the cobalt core of the structure has been highlighted. From the menu, you can also view the pack structure if you wish. In this case, we see that there are 2 molecules per unit cell. As a quick tip, if you want to show the aromatic rings in the conventional CSD style, you can also access this from the drop-down menu. If you wanted to export these results to view them in Mercury, you could click on the Analyze Hit List and Visualize Structures. Had we specified 3D parameters during our search, we could have clicked on Analyze Data, and that would have exported the 3D information. If you want to export the entries in other formats, you can do so from the File menu. The file type currently selected is a ref code list that can be opened in Mercury, and you can navigate to a suitable location to save this using the pop-up. If you want a summary of the search, you can click on the Search Overview, and that tells you the various options that you selected during the search setup stage, and also gives you a summary of the queries that were built. You also have the option to save the search using the File menu and selecting Save Search. If you're on the Queries tab, you can select File and Save Queries. This can be very convenient because you can subsequently read them into another Conquest session. In the Manage Hit List tab, you can rename your hits and find other details. If we'd had separate searches, we could have combined them in different ways using the Combine Hit List functions. This concludes the demonstration of Conquest. For further resources, check out the links in the description. Thank you for watching, and don't forget to subscribe to our YouTube channel.